Hi, I'm Nathan Tracy from TE Connectivity, where I'm a technologist on the system architecture team. And I wanted to talk to you for a few minutes today here at DesignCon 2024, where TE is demonstrating the technologies that we've developed that are enabling the next generation cloud and telecom architectures to support and implement AI, ML type of computing structures. So with this paradigm change in the industry, we need to tailor the product performance specifically for those requirements. And the first demo I'd like to show you is a demonstration of our Adrenaline Slingshot and our Adrenaline Catapult connector systems. In this demo, our demo partner is Marvell, and their silicon is providing 200 gigabits per second onto a line card, which goes to our Adrenaline Catapult connector system. It's a near chip connector system, and we have 250 millimeters of line card cabling to the backplane. And the backplane is our Adrenaline Slingshot connector system, and here we're going over 85 millimeters of twin X cabling to the second line card, where the Slingshot connector now transitions into the line card printed circuit board, back onto the test system and down into the Marvell receiver. And in this case, we're demonstrating performance in the range of 5e to the minus 7 BER. So demonstrating that these interconnection systems are capable of supporting 200 gigabits per second and enabling these flexible architectures that are going to be required for chassis-based AI ML fabrics. So in this demo, I want to show you our CDFP connection system, which is optimized for the PCIe next generation fabric. In this demo, we're demonstrating 4 meters of passive copper cabling, so that's 4 meters of reach over the CDFP connector system, which enables 16 channels at PCIe Gen 6 data rates. In this case, the overall loss of the channel from package to package is about 36 dB, and we're showing a BER of e to the minus 7 in this case. So the key thing that we're showing here is that a long reach, low latency connection can be implemented over PCIe Gen 6. Again, this is a critical enabler to AI ML architectures, and here you see the active demo. So here we're showing a mock-up of what an actual application might look like using the CDFP connection system, and we're showing two different versions. This is the 16-lane version, and then this is the 8-lane version. So the CDFP connection system enables us to scale it from 16 lanes even all the way down to 4 lanes, so that in the end use, the customer is able to implement this low loss, flexible cabling system for disaggregation or box-to-box type of PCIe link applications. So the next thing I want to talk to you about, so we've talked about the interconnection systems that we have that we're delivering for these next generation architectures. And in these applications, it's all about flexibility. And so to support those customer applications, we have to come up with a number of different configurations, such as here you see a chem connector that transitions directly to cable. So it makes it very easy to implement a low loss transmission line within a server or compute box. And what we've done is taken this technology where we go chem to cable and gone to a next generation where we're transitioning directly from the chem connector to the cable, eliminating the printed circuit board. So this is our next generation version. And as you can imagine, there's no end to the special requirements that our customers challenge us to come up with. In addition to cabling inside the box, TE provides a full suite of next generation I/O solutions as well, all the way from 25 gigabits all the way up to now the new generation of 200 gigabits per second. So all the different industry form factors are supported in our next generation developments. So these are used for these high bandwidth, low latency fabrics that are interconnecting all of the GPU applications. As you can imagine, working at 200 gigabits per second, the power dissipation increases, and that's where TE is developing thermal management solutions, such as our thermal bridge technology, that helps our customers make the transition from an air-cooled fabric to a liquid-cooled type of system, where we create the thermal transmission between the pluggable I/O product to the cooling system. So whether it's air-cooled or liquid-cooled, we're enabling those next-generation architectures at TE Connectivity. And so finally, the missing piece that we haven't talked about yet, if we're going to enable the implementation of all these higher speed systems, is to figure out how to deliver power to the infrastructure. And here behind me you see a full suite of power delivery systems that TE provides to our customers that enable delivery of higher and higher power to the rack and chassis level, and in fact even implementing liquid cooling into the bus bar systems to enable the delivery of those next generation power levels. So what we've talked about today is the total suite of connectivity solutions that TE is bringing to the market. The next generation of data center cloud compute is going to bring tremendous challenges in terms of data rate, density, latency, and power, thermal dissipation. And we've seen pieces of that here throughout the booth at DesignCon 2024. Please contact us. We have all the technologies and the early prototypes of these 200 gigabit per second systems that will enable you to implement next generation solutions.